This is probably the hardest part, calculating the error bars for the graph. There are 2 bits and it takes quite a lot of number crunching. Okay, so let's first look at errors in x. Well, actually, technically, we're plotting root x, aren't we? So it's errors in root x. Right. Now, we use the equation for this. So the error in the square root of x over the value of the square root of x is equal to what we calculated it from. So this is the same as where we'd get combining errors from, but we're not combining any errors. We're just literally saying, okay, this came from delta x, so it's delta x over x. We can rearrange this to give us the error that we want. So that would give us error in root x equals delta x times root x divided by x. And with a little bit of algebraic manipulation, we can say, so the error in root x, which is what we want, cancel these things out a little bit, we just get x over root x. Okay, so what you need to do now is go back to your table. You had a value of x and a plus or minus, and that was in meters. And now you're calculating the error in root x. So you also had a root x column in your table as well, with no plus or minus in it. Right, so let's just be clear about where these things are coming from. You might not have had these columns looking quite like this. They might have been spread out, but you're going to have to go back and find that data. So where this number comes from, which is this, is the uncertainty in x. That's this value here, divided by the root of x, which is this value here. So you can calculate what the uncertainty in x is, but you're going to need to do that for each row in your table. So you've got 6 rows, you're going to need to do that calculation 6 times. That gets you all of your uncertainties in x. So remember that the graph we're dealing with is t against root x, and you've got a plotted point. So what this is doing is it's giving you the error bar in the x-axis, which is that way. Now you might find when you've calculated these, they're too small to show up on the graph. Don't worry, if that's the case, then you just take the worst of them that you've calculated, round it perhaps, and put it in the axis label. Don't forget to include the unit as well. Okay, so that does the error bar in one direction. We also need the error bar in t. That takes a little bit more thinking about. Error in t. Okay, so t was based on repeat readings. So we had 10t1, 10t2, 10t3. The average of those, value for a single t. Now what I want is delta t. That's the error in t. So to get that, what I really want is the error in a mean. I actually need an extra column. I'm going to need to work out what the uncertainty in 10t was. And to get that, I'm afraid I'm going to need another column. I need the standard deviation. So in my results table, I've got repeat readings here, here, and here. So the first thing I need to do is work out the standard deviation of my repeats. So you need the standard deviation formula, and there's a little bit of help elsewhere earlier on how to do that. Then the next column is the standard error in 10t. So what we do here is we take the standard deviation and we divide it by root n. In this case, you've got 3 repeat readings, so that's always going to be divided by root 3. If you do have 4 repeat readings, you're going to need to divide it by root 4, or whatever. But we don't want any of those things. We want the error in t, or delta t, whichever you want to call it. In which case, just take this value here and divide it by 10. So the error in 10t, you can get the error in t just by dividing that number by 10. Nice and easy. And that gives you your uncertainty in delta t. These are your y-axis error bars. So for each of your plotted points, you'd now have an error bar that runs that way. Again, you might find that these are actually too small to plot, in which case, once you've worked them all out, you can put the worst one as a plus or minus on the axis label instead. But make sure you've got all of the calculations for these written out. Now, it's really important at this point that you do have these calculations in your lab diary. You don't need to show every single one, but you do need an example of each type. So I'd need to see a calculation of at least one X error bar and at least one Y error bar. And you need to make sure you've included calculations for everything else as well, including the means, standard deviations, every step. You don't need every single calculation, but one example of each is a must to get full marks.